Okay, so let's do an example of an improper integral of type 1. This is an integral from negative infinity to infinity of x cubed times e to the minus x to the fourth dx. If you recall from the video on the introduction, what we want to do is separate, well, first off, let's just notice that the integrand x cubed e to the minus x to the fourth is in fact continuous on the entire real line. So we can actually split this up any way. So let's split this up at 0. Negative infinity to 0 of x cubed e to the minus x squared dx plus the integral from 0 to infinity of x cubed e to the minus x squared, x to the fourth, excuse me, dx. If both of these integrals converge, then the original interval converges. If either of these integrals diverge, then the original integral diverges. So let's work on this. Let's look at the first one, or the first one, yes. So we're going to look at the integral from negative infinity to 0 of x cubed e to the minus x to the fourth dx. And as we noted in the previous video, this is a limit. X goes to, t goes to negative infinity of the integral from t to 0 of x cubed e to the minus x to the fourth dx. So how do we want to approach this integral? Give you a moment, pause it, see if you can think about it before I tell you. Spoiler alert, yeah, we're going to let u equal e x to the fourth, and then du is going to equal 4x cubed dx. And we have an x cubed here, so that makes it a reasonable substitution. 1/4 du is equal to x cubed dx. That's good. And if x equals t, that tells me u's equal to t to the fourth, right? And if x equals 0, that tells me u's equal to 0. So this is going to be, let's go back to the green, the limit as t goes to negative infinity of the integral from t to the fourth to 0 of 1/4 e to the minus u du, which is the limit t goes to minus infinity of negative 1/4 e to the minus u, evaluate it from t to the fourth to 0, which is the limit as t goes to minus infinity of, at 0 I just get e to the 0, which is 1, so I get minus 1/4, minus and minus, so that's plus 1/4 e to the negative t to the fourth. Minus 1/4 just goes to minus 1/4 as t goes to minus infinity. As t goes to minus infinity, t to the fourth goes to infinity, so minus t to the fourth goes to, guess what, minus infinity. So that part here, this part here is going to, well, as minus t to the fourth goes to minus infinity, e to that goes to 0, so that whole thing goes to 0. So this limit's going to be minus 1/4. So this first one is minus 1/4. It converges. The second one, well, the second one's going to be very much the same. Why don't we do that one in blues, huh? It's going to be the same antiderivative. So let's get to the end. Well, 0 to infinity of x cubed e to the minus x to the fourth is equal to the limit as t goes to infinity of the integral from 0 to t of x cubed e to the minus x to the fourth. We're using the same u substitution. So this is going to be the integral, this is going to be the limit as t goes to infinity of that u substitution. The same u substitution here is going to be 1/4 e to the minus u du, and u, when x is equal to 0, u is equal to 0. When x is equal to t, u is equal to t to the fourth. And so that's going to be the limit as t goes to infinity of 1/4 e to the minus u from u equals 0 to t to the fourth, which is the limit t goes to infinity of 1/4 e to the minus t over 4, t to the fourth, minus 1/4, right? And as we noted before, as t goes to infinity, this thing goes to 0. So this entire thing is going to go to minus 1/4. So this thing here goes to minus 1/4. And we get an answer of, oh, wait a minute, that's minus here. Okay, so that's minus, minus, plus. So this goes to positive 1/4. So we get an answer of minus 1/4 plus 1/4, which is 0. So this thing actually converges to 0. And it makes sense because this is an odd function, right? So it's going to be kind of symmetric around the origin. On the negative side, it's going to be below 0. On the positive side, it's going to be above 0. So it seems reasonable that if it converges at all, it should be 0. But we need to make sure it converges at all before we say that answer is 0. And it is. So it converges. And we are done.